So today we'll continue from where we ended last time. So we are still on problems, review problems for test one. And then just to remind you that your test one is on Friday. So last time we ended at question 19. Today we'll proceed from question 20. For question 20, we are asked that the number of people on the jury. What do you think that should be? Why? Yeah, because it's a number. Usually they are odd. It could be 5, 7, 9, depending on the situation. Let's go to 21. So for 21, we are given these numbers here. And then we are asked to find the mean. So to do that, if you brought your calculators, it's easier to do that. Or you could also use StatCrunch to do that. So let's use StatCrunch to do that. So you go to StatCrunch and then you input the numbers. We want the mean, just the mean. So we go to start, summary starts, and then columns. We hit on var1 because that is why I stored or that is why I inputted my numbers. And then what do I want? I just want the mean. I hit compute. So the mean is what? 15.6. On the exams, you'd have problems like this. So you should be able to decide what you need to do. Are you going to use StatCrunch? Are you going to use your calculators? You are not allowed to use phones. So if you are using StatCrunch, it is advisable that you learn how to do that now. Is that okay? Because on the exam, I cannot help you. So you should know that if you are looking for the mean, you go to stats, summary stats, and then choose the column you inputted the data, and then hit whatever you want to compute. Does that make sense? Let's proceed. So we found that the mean was 15.6, which is C. Let's get to 22. So for 22, we have been given this test course, and then we want to find the upper hinge. Last time we learned that the lower hinge is the same as Q1, and then the inter hinge is the same as the IQR. Upper hinge is the same as Q3. Is that okay? So you should be able to know this. So in case they ask you to find the upper quartile or upper hinge, you should know they mean the same. So you know. So now we want to find the upper hinge. And we have this data set here. So it is good that we are able to use StatCrunch to compute that. Is that okay? So let's get to StatCrunch and then input the numbers. So you can input the numbers by yourself. I also do mine, and then we could all double check and find out which is the correct one. Or if you're also having challenges, then I could also be able to assist you. So I have successfully inputted my numbers. I was told that the test scores are for 19 students, so I could see from here, I have that 19. And then we want to find the upper hinge. I have already told you the upper hinge is the upper quartile. So to do that same stat, summary stat, we go to columns. We hit variable 1, or you could also rename variable 1 if you want. But if it's an exam, I won't recommend you doing that. You save time. Is that okay? Just know you inputted a data set on variable 1. And then we just need Q3. So we have Q3 here. And then I got 83. Did you all get 83? Good. Okay. So it means you're on the right path. Good. Now let's proceed. So it means that the upper hinge is 83, which is A. Let's get to 23. The color of your house, is it categorical or quantitative? Yeah. So it's categorical. Good. Let's get to 24. So for 24, we've been told that this is the histogram and then the summary statistics for reading scores of 29 fifth graders. So you see here, we don't have the scores, but they've summarized those informations for us. Is that okay? This is the histogram. So what comes in mind? What type of histogram is this? Is it skewed or symmetric? It is skewed, right? Is it skewed to the left or skewed to the right? How many of you think it's left? Just show by your hand. How many of you think it's right? Okay, so it's skewed to the left. Is that okay? You can see the tail is pointing towards the left. Is that okay? If you try to draw a curve, you see the tail is pointing towards the left. So we agree that this is what? So immediately we see this, let's take note. This histogram is what? Left skewed. Is that okay? That is the idea we've seen here. We could also use this summary statistics to be able to what? Confirm that. So for left skewed, we can see that what? The mean is less than the median. You can see from here too. Is that okay? That also confirms that. And then we have this summary statistics. Now the question they want to ask us is, which measure of center and spread would you use for this distribution? So this question just wants us to be able to answer. Because this is skewed, last time we learned that the measure of spread for skewed distribution is what? IQR, isn't it? Because we know that what the interquartile range, it's more resistant to outliers than the standard deviation. And so the measure of center too, instead of using the mean, we are going to use the median because this is what? A skewed distribution. Is that okay? So for the measure of center, it's going to be the median, and then the spread would be the IQR. So you see the question says measure of center. So the measure of center comes first in the solutions. Is that okay? So when you look at that, we have C, A and then C, which means A and C has median. So we know for skew distribution, the best measure of center is what? The median. So the answers are competing between A and C. And then we also learned last week that for spread, we want to use the IQR for skew distribution. And so we can see this IQR here too. And then you see the reason, because the data is what? Skewed to the what? Left. Is that okay? And so the right answer should be C. So you see in this situation, you don't even need the scores because all they want to test is for you to be able to, one, identify this to be a left skew distribution, and also know that whenever you have skew distribution, what is the best measure of center? Is the median. Spread, IQR. If it is symmetric, the best measure of center is the mean. The spread, standard deviation. Is that okay? Let's proceed to 25. So 25, we have these numbers. We are told that a store manager kept track of the number of newspapers sold each week. And since we have these numbers, we are asked to compute the median. So straight away, go input these numbers, do them by yourself, because on the exam day, you are going to do them by yourself. Is that okay? So try to open your StatCrunch, input these numbers, and then find the median.
Entering data in the StatCrunch like this, especially like when it's like a chart and there's like a lot of numbers, does it matter what order you put them in?
It doesn't matter
Okay.
because StatCrunch automatically sorts them before it computes.
Okay, that's what I was
But
thinking.
if we are solving, then we have to order it. Is that okay? Good. Anyway, that's a good question, by the way. You could also try if you get to any, if you, in case we have any data, input it any way you want and see if you also get the same answer. So I come to StatCrunch. And then I input my numbers. And then you go to stats, summary stat, columns, and then you want the median. So the median is this. And then we hit compute. I got 230. Did you guys also get 230? Okay, sounds good. And so let's proceed now. Let's get to the next one. So with this here, let's try to take notes of the information we have here. So let me give you a minute to read this sentence, the information. That way, when you spend time to read, you can be able to understand what is required of you and how to go about it. Okay, let's start now. We are told that a magazine article reported on Springfield School District's magnet school programs. And we are told that out of 1631 qualified applicants, 892 were accepted. So let's write accepted to be 892. And then we are told that 292 were on wait listed, or 292 were wait listed. So wait list. Wait list is 292. And then 447 were turned away for lack of space. So turned away is 447. We are asked to find the relative frequency distributions of the decision made and write a sentence describing it. So let's try to find the relative frequency of accepted, wait listed, and then turned away. How do we find the relative frequency of accepted? So it's going to be, we know that the total accepted is what, 892. So it's going to be the total accepted divided by the total qualified applicants. Is that okay? So try to do that. What do you get for accepted? 85%. Did you all get that? 55. Okay, sorry. Did you all get 55%? So how do you go about it? It's going to be what? Accepted is what? 892. So 892 divided by 1631. Is that okay? So that is 55%. Good. Now let's get to waitlisted. What did you get? 18%. So how do you get that? 292 divided by 1631. And then let's go to tend away. 27%. And so when we read these possible answers here, we can see that B matches our answers. And you can see 1631 students applied for admission to the magnet schools program. 55% were accepted, which matches our answer for accepted. 18 were waitlisted, which matches our answer. And then 27% were turned away. Is that okay? Do you guys have any questions on how to compute this relative frequency? Okay. You could also use StatCrunch to also do that. And I think we've done that before during the first time. But because this is just three of them, it's easier to do by hand. Is that okay? Now let's get to 27. So I want you to spend time to read that and then answer the who, the what, why. Is that okay? And then when you do that, you share your answers. Okay, so let's do it together. Now, if I were you, because this is multiple choice, I'll try to be smart about it by reading the problem and then looking at the possible answers. Is that okay? So, for example, when you read the problem, it says that a survey of bicycles parked outside college dormitories at a small university recorded the style, the band, the color, and then the age. So when I look at the possible answers here, I see who, I see cases, I see what, I see when, I see where, why. So now let's try to answer some of the easy ones we can. Is that okay? The easiest one we can answer is where was it recorded? So who would help us? Mm-hmm. So we know the where was what? A small university, isn't it? Can you all see that? So the where is a small university. The next thing you want to answer is what? What was recorded? So you can see the style, the brand, the color, and then the age. Is that okay? Those are the variables. Does that make sense? So you see what was recorded: the style, the brand, the color, and then the age. So we've been able to answer where and then what. Now, even with those answers alone, let's get to cases. Remember, cases are the what? The rules. Those are the individual bicycles. Is that okay? Which we all know that. So when you look at these possible answers here, let's go to the where and then the what. So when you look at question A, the what is type of dormitory. You see that one is out. Is that okay? A says that what is the type of dormitory, but our what that we know is what is the style, the brand, the color, and then the age. So that takes A out. Let's get to B. So B has what we want: the style, the brand, the color, and then the age of the bicycle. Right. And then how about the where? The where is also correct. And then the cases, so we have B in mind. Is that okay? So here we see we are trying to eliminate. So we have B in mind. Let's get to C. C, the what is the size of the matrix? So you see C is also out. Is that okay? Let's get to D. The D says that the what is the what? The mountain bikes 10 speeds. No, but the what is what? The style, the the brand, the color, and then the age. So you see that one is also out. And then E has a style, the brand, the color, and then the age of the bicycle. So it means that the answers that are in contention are B and then E. Is that okay? So just answering just these few ones helps us to be able to see which ones are in contention. And so now let's get to the why. Why was this information recorded? Not specified, right? Okay. So let's see. The B says class assignment. So you see, this is what not specified. Is that okay? So you see, when you have multiple choice, you don't necessarily have to answer all the five. You'd have to, if I were you, to save time, I'll be doing them step by step and be eliminating. Does that make sense? Any questions so far? Are we all good? You should be able to know how to identify those where, how, and what have you. So the who, you could also see the bicycles that were parked at the what? The college dormitories. Is that okay? Let's get to the next one. So the next one here, we were given the box plots. So these are box plots. And what is the information? They are saying that here are box plots of the points scored during the first 10 games of, I think maybe here is baseball season for both Caroline and Alexandra. And we are asked to summarize the similarities and the differences so far. So just looking at this, what similarities can you see? The same median. Good. So you can see that, look at the median is this one. You see they are the same, right? Remember when we learned about box plot, I spent the time to show you how to label them. Is that okay? This is Q1, median, Q3. Is that okay? Q1, median, Q3. So you can see the median is the same. And what are the differences? What differences can you see? So when you want to look at the differences, the first thing you can see is that look at the box here. It's shorter than this box here. Can you see that? The box for Caroline here is shorter than this one. Can you see that? And what is the name of that box called? IQR. Is that okay? So that is the interquartile range. Can you see that? So if the IQR is shorter, it means that what? It is consistent, right? If the IQR is shorter, it means that what? It is consistent. That is the theoretical meaning. If the IQR is longer, it means that there is a large variation. I remember giving you the example with the playground and stuff like that. So just know that when the IQR is shorter, it means that it is what? Consistent. So let's look at so you see with this one here, you don't need to know the exact numbers. Is that okay? But you could be able to what? Guess. Does that make sense? So when we look at A, it says that what? The girls have different average score per game. And then Caroline's is much more consistent because her IQ is about 4%. It's 4 points. What is the IQR? IQR is this box, which is what? Q3 minus what? Q1. This is Q3. This is Q1. So you can see Q3 is around 20, and then Q1 is around 16. Can you see that? And then here Q1 is around 10. This is more than 25. But then the median is what? The same. So we will not take A. And then let's get to, let's get to this one. B, it says that the median score is about 18 per game, which is almost true. And then it says that their IQR are different, which is true. But the IQR does not give any more information on the girl's performance. It does. It tells us that this Caroline's performance is more consistent. So B is also out. So you go through and then we get to E. So you see, both girls have a median score of 18 points per game. So it means that the median is the same. Is that okay? And then Caroline is much more consistent. It is true, Caroline is much more consistent because the IQR is shorter. Is that okay? If your IQR is shorter, it means you are more what? Consistent. Because the IQR is about 4 points. And then Alexandra's IQR is over 15. So, like I said, when you have this, you don't need to have the exact number, but you could be able to tell that this is more than 25. Even let's say this is 10. So IQR is what? Q3 minus Q1. This is Q3, this is Q1. That is how they got those numbers. Is that okay? Any questions so far? So the right answer is E. Let's get to 29. 29, we are told that these are the test scores of 15 students. You are asked to find the 5-number summary. So what are the 5-number summary? Who can help us? The 5-number summary in order. What is the first one? Minimum. Good. So the first one is the minimum. What is the next one? Q1. Good. What is the next one? Median. Good. What is the next one? Q3. And what is the last one? Maximum. Good. That's nice. It means you guys are prepared for the test tomorrow. So now try to input these numbers here in StatCrunch and then compute the 5-number summary. Okay? So for the 5-number summary, we go to stats, summary stats, columns. I hit that. So the first one is the minimum. I look for that. I click on that one, followed by Q1. I'm using a Mac, so my hand is on command. And then I look for Q1, followed by the median, and then Q3, and then the maximum. So you see, I have my 5-number summary this way. And then we hit compute. So this is our 5-number summary. So we have 41. The next one is 55. So you see, they want you to be able to know the order. Is that okay? So you should be able to put them in order. Otherwise, you might not get it correct. So the minimum is 41, Q1 is 55, Q3 is 71, a median is 71, and then Q3 is 87, and then maximum is 95. So I think that order is not listed, so it has been corrected. So you could see the answer is at the bottom. Is that okay? 41, 55, 71, 87, 95. Even if you compute and then you mix the numbers, for example, you do Q1 first, minimum, you are not going to get it right because they expect you that you should be able to know the order of the 5-number summary. Is that okay? Let's get to 30. So I'll give you a minute to be able to read the problem and then we'll proceed from there. So the summary of the information is that Jamestown has a large hospital and then a small hospital, and both of them perform major and minor surgeries. And then this data here is collected at each hospital to show how many surgical patients have their discharges delayed by post-surgical complications. So now that we have this information, what is the question expecting us to do? It's asking us what are the discharge delay rates for each kind of surgery. So to do that, remember, this thing is looking like what we learned with the Simpson's paradox. Is that okay? So to be able to find the um, the discharge delay for each kind of surgery, remember we have two types of surgeries. We have the major surgery and then the minor surgery. And so the right way to go about it is that how many of the large surgeries we had were delayed? So 90, right? So 90 plus 9. Is that okay? That gives us 99. Is that okay? Divided by the total, 900 plus 60. That gives us 960. Is that okay? And so what is the answer? The answer is going to give us 99 divided by 960. How did I do that? I'm looking for the discharge delay for each kind of surgery. This is major surgery. So I start with major surgery. So I write major surgery. And then look at large and then a small hospital, 90 and then 9. So 90 plus 9 divided by 900 plus 60. What do you get?
10.3%.
10.3%. Now let's get to the other one, minor surgery.
25 or 550.
Yeah, so you see 20, 15. 400 and 150. So that is 35 divided by 550. But what do you get?
6.4%.
6.4. And so that is E. Let's get to 31. So the speed of car in miles per hour is quantitative, right? Because you could be going 50 miles per hour. You could be going 60, 75, and 70. Because if you go above 75, I think that is a violation. So you don't want to do that. And then, so we'll end at 31.